Okay, so I'm going to try this again. Simplifying radicals um, is should be a review, but if it's not a review, then welcome to Simplifying Radicals. All right, so I would recommend that you memorize the perfect squares at least through 225, which is 15 squared. Um, it's just helpful to have them memorized. Perfect cubes, this is through 8. I would recommend taking some time to memorize those because that's going to make it easier. I also had just mentioned that the square root of 16, most people think of as positive 4, but it's really plus or minus 4 because if you think about it, what it means, 4 times 4 or 4 squared is 16, but so is negative 4 squared, negative 4 times negative 4. So here we're going to account for that, but when we get down here, we're just going to be using the positive root when we're talking about the square roots. All right, and the cube root of 343 is a perfect cube, which would be 7. And that's that. All right, so when we're going to be doing the ones that are not perfect, basically you need to use factors of the factor tree, take out what you can, and re-multiply the stuff that's kind of left over. That's kind of how it works in my head. Um, Ideally, you can recognize that the numbers are divisible by some of these, and that can make it go quicker. So I'm going to kind of go with it that way um, and show you kind of what I mean. Because in Algebra 1, you probably learned to just keep factoring, but I'm going to show you kind of the Algebra 2/advanced math way. When you make your factor tree, I'm always thinking, okay, so what perfect square could this be divisible by? And in my head, I wanted to try 9, so I did, and it was 9 and 13. Now, normally you would have broken down the 9 and pulled out stuff, but I look at it like this. The square root of 117 is the same as the square root of 9 times the square root of 13. Well, we know the square root of 9 is 3, and the square root of 13 is left. So that's the answer. Now, usually I kind of do it without this step. I just look at it that way. What's the square root of 9? 3. What's the square root of 13? And just write it like that. All right, the next one, 320. So I'm going to try to see, I mean, obviously that's divisible by 4, but I feel like it's got to be divisible by maybe 16. Nope. So what I'm doing over here is I'm just trying the perfect squares. 320 divided by 4 for sure, but more than that. 320 divided by 16 does work, okay? All right, and there's even more than that, so let's try it again. 320 divided by 64, oops, is 5. Hey, that works. So I'm going to say 64 times 5. 64 is a perfect square, so think about doing it like that, okay? So 4 times the square root of 64, which is 8, root 5. So the final answer for this one is 32 root 5. Now this next one is a cube root. So we need to make sure that we have a perfect cube that we're dividing by. Well, 48 is divisible by 8. So in my head, I'm going like this. 8 times 6 is perfect. And now I'm going to take the cube root of each. So we have 2. The cube root of 8 is 2. And then we have left the cube root of 6. And then we're going to multiply these 2's. Okay. And just as a side note, can you check your answers in Desmos? Of course you can. Let me pull up Desmos. Probably should have had that already. And you can just, actually, I'm pretty sure you can. Let me make sure. 2 times the cube root of 48. Oh, I guess you can check it that way. And then 4 times the cube root of 6. Ah! And they're exactly equal, which means we got it right. So that's one way you can check it. All right, this next one is 6 times the cube root of 2, And I think I meant for that to be 216. So let's change that. All right, so 6 times the cube root of negative 216 would be, this is perfect, so 6 times negative 6, which is going to be negative 36. All right, a couple more now with variables, I think. Okay, so with variables, what you're looking at is to make sure that your exponent is divisible by the number out here. So the first part is, what perfect square can I divide 32 by? I'm going to say 16 and 2. Okay, so we know that this is going to be 4 on the outside and the square root of 2 under the radical. But here we have x to the 4th. So all you really have to do is divide 4 by 2 and you get x squared, because really we have this, right? 2 groups of 2. Now we have y to the 9th. So a lot of the time I would write this problem kind of more like this. The square root of 16 times the square root of 2, the square root of x to the 4th, the square root of y to the 8th, and then the square root of y. Because this is 9 y's, but this is an even exponent. We can divide it by the 2 of the radical, so that would be a 4. So we did this one, we did this one, we did this one, and now we have a y remaining inside. That was a very strange explanation. So hopefully I'll do a little bit better on this next one. All right, negative 81 is, let's see, the cube root, I think it's divisible by 27. Yes. All right, so this is going to be negative 27 and 3. So I'm going to kind of do this the long way. We're going to have the cube root of negative 27, which is a perfect cube, the cube root of 3, the cube root of p squared, and the cube root of q to the 12th. This is a perfect cube. So the negative 3 goes on the outside. This is not a perfect cube. This is not a perfect cube, but this is. We have 4 groups of 3. So q to the 4th, 12 divided by 3. We're left with 3 and p squared, the ones that were not perfect cubes. All right, 2 more. This one, we want the 4th root of y plus 3 to the 8th. Now keep in mind, because this is parentheses, it's one quantity. So all you have to do is divide 8 by how many groups there are? 4. So we're going to have y plus 3 squared. That's the final answer. And just a little reminder, y plus 3 squared means y plus 3 times y plus 3. It does not mean y squared plus 9. All right, last one. Now, I myself do not know all of the perfect fours, whatever they're called. I don't even know what they're called. But I see 625 looks pretty nice. And I think it's 25 times 25, which it is. And both of those are perfect squares. So it means that this must be perfect if you think about it like this. There's 4 of them. So again, we're going to kind of follow that same thing. That's a perfect 4th root. 23 is not divisible by 4, but 20 is. So I'm going to put c to the 20 and then the 4th root of c cubed. That's 23 of them. 11 is not divisible by 4, but 8 is. So I'm going to put d to the 8th and d cubed. Now we're going to take all the perfect ones. 5, c to the 5th, I divided. D squared, I divided 8 divided by 4. And we're left with c cubed, d cubed under the radical. All right, that was a very strange explanation, but hopefully it helped you understand. Have a great day.